Alright, so here's our read and got it's for 5-4. Talking about point slope form of a line, so another form of a line. As I mentioned in vocab, there's very specific rules for this. So first off, again, just reviewing that whole definition before we start doing anything. The point slope form of a line, it's an equation, right? Non-vertical line, obviously. And using a point and the slope all put together. Now remember, again, I keep stressing this point, we notice that there's subtraction involved. So if I have minus here, the coordinate's positive, right? Minus here, coordinate's positive. But if this were a plus here, that would be a negative coordinate, so because negative times negative is positive. And here's again kind of a breakdown of what the different parts are. And again, the graph, where the parts come from, any point, and the slope, you can put this together. So it could look very different depending on what point you pick, but it's still, we can prove that it's still the same line by translating it into one of the other forms. And again, here's why it works down below, just for the fun of it. Given a point x1, y1 on a line and the slope's m, you can use the definition of slope to derive point slope form. So that's literally where it comes from, calculating the slope and then deriving that point slope form from that. So, all right, on the next one we're going to have some practice here. So we start out writing an equation in point slope form, just like we did in vocab. If I give you a point and a slope, it's pretty straightforward stuff. Again, the formula itself is y minus y1 equals the slope m, and in parentheses, x minus x1. So I plug in my points and notice a positive 6 down here, so it's y minus that 6. Slope of m, that's negative 5. X minus negative 3. That's where we get that x plus 3 down here. So again, make sure you pay attention. That's one of those things that kids get hung up on when they're working. And you got it. We can just handle that right here, right now. A line passes through the following point, 8, negative 4, has a slope of 2/3. So y minus, right, negative 4 equals 2/3 times, it's a 3, I promise, times x minus 8. Obviously over here we've got this double negative thing going on, so we're going to have y plus 4 equals 2/3 times x minus 8. And again, leaving it in point slope form, I know you'd be tempted to probably want to distribute this 2/3, but in point slope form we don't do that. Now at some point you'll have to, if I ask you to translate it to another form, and we will do that. We'll have a fair bit of practice at that. So graphing from point slope form, it's actually pretty straightforward. I give you a slope, and I give you a point. In this case, we can see the point is going to be positive 2, positive 1, and a slope of 2/3. So you literally graph that. So graph 2, 1, and then up 2 over 3. Put another dot. And take your ruler and connect the dots. It's pretty much that straightforward. So again, the way that looks. Graph the point that's in here, 2, 1. That goes there. And then count the slope. Up 2 over 3. Put another dot, and connect the dots. On the next slide, we're actually going to graph that then, this one down here. Okay, so let's go ahead and graph this. We need to make sure we sort of pull a point out of here, right? So, oh, you know what? I need to put the x and y axes on here. Just a second. All right, so the point we get out of this one, this is 4 and negative 7. So 4, negative 7. So we're going to graph that real quick. So I've got down, let's see here, so 4. So here we go. 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, right there. So let's count that again and make sure we count that right. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. There we go. That's pretty close to being right on when I did that. And then we're going to count our slope. Our slope is going to be negative 4, 5. So that means I'm going to go down 4. So let's grab this here. 1, 2, 3, 4, and then 1, 2, 3, 4, 5. Alright, oops, there we go. So 1, 2, 3, 4, 1, 2, 3, 4, 5. There we go. And then we just go ahead and play connect the dots. So grab another thing here. There we go. And oops, hang on a sec. My marker gave out. Touched the wrong thing. It's tougher than you think to graph on an iPad. So there you go. And that's our point slope form. All right, so here's where it gets a little more challenging. Using 2 points to write an equation. And so it's not that it's more work. Not that it's difficult, but it's more work. So I give you 2 points. you can use those to calculate the slope. So that's the first thing you want to do. Use those 2 points to calculate the slope. And then, right, so like right here, and then you go back and you take one of those 2 points. It doesn't matter which one. And you plug those back into your point slope formula, and then just throw the slope on the outside. So again, if I had the following 2 points, -2, -3, and 1, 4, use those right here to calculate the slope, and then grab one of those 2 points. It doesn't matter which one. In this case, we grabbed 1, 4, and plug those in down here. So here's your +1, here's your +4, and your slope of 7/3 on the outside. Next slide, we're going to actually go through and do the work on that one. Okay, so for this reading, got it. It says in the last problem 3, use the point -2, -3 instead of 1, 4 to write an equation of the line. So rewrite the equation in problem 3 in slope-intercept form as well. So we're going to use a different point, so we're going to use that -2, -3 to rewrite it. So we're going to have, again, as a reminder, it's y minus y1 equals m times the quantity x minus x1. And so we're going to take y minus -3 equals m times x minus -2. Now obviously we need to correct that a little bit. It will become y plus 3 equals m times the quantity x plus 2. And what it wants to know then, rewrite it in slope-intercept form. So this is where it gets to be really fun. And I'm going to transfer this to the next slide so we have a little more room with this so we can do part B here. Made a mistake there, by the way. Forgot to put in the slope of 7/3. So there, that pops in for you real quick. So the way this works, we've got to start with some distributive property. So y plus 3 equals 7/3 x plus 14/3. Subtract 3 from both sides. Looking familiar, right? Y equals 7/3 x plus, and so we need 14 minus 3 here. So this part over here becomes 14/3 minus rather, let's erase that there. There we go. Minus 9/3, and so that's going to be something thirds, right? So you have 14 minus 9, which is 5. So there we go. So it becomes y equals 7/3 x plus 5/3. That's a little better. And so we're going to rewrite the other one the same way and going to see if we get the exact same equation. So now the first equation they gave us that was generated in the example was y minus 4 equals 7/3 times x minus 1. And we're going to prove that that is the same as the last one we just did. So no matter which point I pick, if I translate into slope-intercept form, it is the same line. So we're going to have y minus 4 equals 7/3 x minus 7/3. There we go. Add the 4 to both sides. And so, again, that's what we're really working with here. Y equals 7/3 x. So we're worrying about -7/3. -7/3. I'm going to erase that. Well, it's just not working out well today, is it? -7/3 plus 12/3, right? Isn't that what 4 is? And yes, that is indeed a positive 5/3. So if you look here, and I can even go back to the last slide, that is the exact same equation that we wrote using the other form or the other point. So again here, what that means is when I talk about point slope form, no matter which point I pick, if I translate it into slope-intercept form, like this, using some algebra fun, then I'm going to get the exact same line. So proving that no matter what point I pick along that line, it still works. Okay, fourth example. The table shows the altitude of a hot air balloon during its linear descent. Right? That means that it's going to have, it's going to have a constant descent. It's not going to speed up and slow down as it descends. What equation in slope-intercept form gives the balloon altitude at any time? What do the slope and y-intercept represent? So here's what we're looking for. Take these points, this point or any 2 points, and calculate the slope. That's what they've done here. They took the, which one did they take? 645.90. Yep, so they took this one, and they plugged those points in here and calculated the slope. They put it in decimal form, which is fine. Then they used the formula for slope or point slope form right here to generate this equation. Then they translated that, like I did in the last 2 slides, into slope-intercept form. That is one of the major expectations of this section. The slope, 2.5, represents the rate of descent. We get that. And the intercept, y-intercept of 665 represents the initial altitude, so where it started, right, as it descended. Because they gave us time in 10 minutes, not time at 0 minutes when it started out. So you can kind of go back in time once you use this. Okay, to start this one out then, you're going to need to pick 2 points. Any 2 points. I'm going to pick these 2. And you're going to have to generate the slope. So do that right now. Okay, so again, we're going to pick a point here to plug in, and we're just going to pick this one and this one to calculate the slope. So we'll call this point 1 and this point 2. So our formula, again, y2 minus y1 equals x2, over x2 minus x1. So let's plug it in here. We'll start with our y2 is 4, 5, 7, 0. It's not a very good 7. Here we go, try that again. 7, 0, minus 3, 3, 2, 0. All that over 3 minus 2. I'll give you a second to do the math on that. So that gives us 1250 over 1 for the slope. So next step then is put it in point slope form. It doesn't matter what point you pick. Any of these 4 would be just fine. So we're going to pick the 3320 and 2. So we have y minus 3320. I'm sorry, 2 and then 3,320. I said it backwards, didn't I? Equals our slope of 1250. Okay, trying that again there. Slope of 1250 times x minus 2. And again, so there is an equation. Actually, there's 4 of them. You could have picked any of these points here in point slope form for this. And again, what does the slope here represent? That 1250, that would be technically gallons per hour, right? So it's gallons per hour is what that means. So that's that second part up here. And on the next slide, it says we're going to write an equation from A, right, from part A, in slope-intercept form, and what does the y-intercept represent there? So let's do that on the next slide. So we're going to take this one over, and we're going to translate into slope-intercept form. Now we should note, I don't care what point you picked when you made your point-slope form. It's still going to turn out to be the exact same slope-intercept form. If it doesn't, you made a mistake. So here's the way this looks. I'm going to switch colors to the front of it. Y minus 3320 equals 1250 x minus, and here's again, don't forget the distributive property, 2,500, because we're multiplying by 2. Now, we're going to go ahead and add, because we're going to solve for y. That's really what you're doing, solving for y, right? We're going to go and add 3320 to both sides. So add 3320. And y we find equals 1250 plus 820. If you want to check the math on that, you're welcome to do so. Alrighty, so it asks us then in that second part, what does that y-intercept mean? And again, that's the initial number of gallons of water in the tank. So if we go back here, so again, going back, you notice that table started at time is 2 hours, not at time 0. So this tells us what it would happen at time 0. So how much was in there beforehand.